Hi students, say here we are doing this expression. So this is, you can compare this and that, or otherwise you can do one more thing. This is I equals E1 R2 plus E2 R1, cross multiply and get an expression for V only. This I told it can be VAC or just V also you can put. So here we can compare this and this. This instead of writing this might be, you might feel like complicated. You can compare that also. I you can get expression E equivalent by R equivalent minus V by R equivalent. Okay, we can do it separately and we can do. But rather than that, what you can do is you can multiply R1 R2 here, R1 R2 by R1 plus R2 I will take, by R1 plus R2. This is R1 R2 by R1 plus R2. It is like multiplying R1 R2 by R1 plus R2. What do you get now? E1 R2 plus E2 R1. We are multiplying E2 R1. R1 R2 cancels, divided by R1 plus R2. Okay, then this will be minus VAC. Come on, you say what I am doing, multiplying with R1 R2 by R1 plus R2. Enough. Okay, so now VAC equals, just take that this side, VAC equals E1 R2 plus E2 R1 divided by R1 plus R2 minus, you will be getting it. Then equate, say that also if you want, just I will be showing it here. You can compare and then you can do it. A comparison, if it is possible, you do it. But this is quite important only. Just you have to go ahead. Now here, what do you get? VAC equals E1 R2 plus E2 R1 divided by R1 plus R2 minus I into R1 R2 by R1 plus R2. Until this, you can write one more step, then compare these two. VAC equals E equivalent minus I into R equivalent, and VAC is this. Then when you compare E equivalent equals E1 R2, little space problem, just you try to adjust. E2 R1 by R1 plus R2 you are getting, and R equivalent will be equal to R1 R2 by R1 plus R2. Obviously this R equivalent you should get R1 R2 by R1 plus R2 only. Reason for that is when two resistors are connected in parallel, what do you get? R1 R2 by R1 plus R2. Little difficult, but whereas most important, you have to practice. Okay, that's it. Now we'll be talking about this Kirchhoff's laws or Kirchhoff's laws. Actually, pronunciation wise, it is Kirchhoff's laws, Wheatson's network and all those things. This is networks. Here also, this and as well as meter bridge, you should know. What are these Kirchhoff's laws means? Very first, I'll just explain what do you mean by network first. Network means electrical components connected in a complicated manner. Electrical components connected in a complicated manner is called as network. Okay, and again here next one more definition, node or junction. It is a point in an electrical network where two or more conductors meet. Okay, then mesh or loop. Any closed path of a circuit, for 1 mark I am telling. Who knows what is an electrical network? If they ask, you can say electrical network is the one in which electrical components are connected in a complicated manner. Node or junction. It is a point in an electrical network where two or more conductors meet. Mesh or loop. What is mesh or loop means? And so this is a closed path of a circuit. Next, let us go ahead a little fast. First law, Kirchhoff's first law. What is this Kirchhoff's first law means? It is nothing but KCL also we call. Kirchhoff's first law. KCL. Kirchhoff's current law we call. Kirchhoff's current law. What is current law means? Just we write KCL. This you take it as KCL. This is like algebraic sum of the currents meeting at a point is always equal to 0. See, just a statement. Algebraic sum of the currents meeting at a point is equal to 0. Okay, that is sigma I equals 0. For this explanation, if you want, take one network just like this. You take few things like this. Let me say one more I am putting here. I1 I will call, I2 it is coming out, I write this I1, I3 is entering, I4 is entering, I say I5 is leaving. How to apply for this means, currents entering the node, take it as positive. Currents leaving the node, leaving the junction, take it as negative. Then I1 plus I3 plus I4 minus I2 minus I5 equals 0. I hope you are getting it. Currents entering the junction should be taken as positive. Currents leaving the junction should be taken as negative. I1 minus I2 plus I3 plus I4 minus I5 equals 0. I1 okay, minus I2 plus I3 plus I3 plus I4 minus I5 equals 0. Then you will get it as even I1 plus I3 plus I4 equals, you are getting like I2 plus I5, meaning of which is currents entering the junction is equal to currents leaving the junction. And again here one more point, KCL follows from conservation of charge. What is the significance of KCL for 1 mark? What is the significance of KCL? You have to say it follows from conservation of charge. Okay. So now next KVL we take. KVL is second law, Kirchhoff's voltage law we say. This is algebraic sum of the product of resistances in any closed path is always equal to algebraic sum of the EMFs. Algebraic sum of the EMFs. Okay. You follow one particular convention and you follow it. In any one particular way you have to follow, and so you will get it. Say one circuit I will be giving. Let me say here this is connected to one cell, and here this is also connected to one cell here. Okay. Here one more I will be taking like this here, one more. I say this is A, B, C, D and E. I mean C, D, E and F I am taking. Okay, here current I will take like this. Usually any method you can follow. Okay, I2 and this is I1. This R1, this R2, this is R3. Because currents are coming this way here, I3 or I1 plus I2 also you can write. And so this way, this will be E1 and this is E2. Applying KVL to the mesh in any way, BA, FCB, or you can call ABCFA, and you can follow in different way also. If I say like this, BAFCB, I1 R1 plus I3 R3 minus E1 equals 0, you can do that. I1 R1 plus I3 R3 minus E1 equals 0. When you are getting negative terminal, you can take it as minus. Then overall what are you getting here is I1 R1 plus I3 R3 plus I3 R3 equals E1. This is one example. Algebraic sum of EMFs present in a circuit is always equal to algebraic sum of the IR products. Okay. For this also same thing, I2 R2 plus I3 R3 minus E2 equals 0. If there are internal resistances, you have to consider even that. Okay. Next, if you are taking for this entire thing, like this, if you are taking, what write in I1 R1 minus I2 R2 plus E2. When you get positive, that is a better conventional method plus E2 minus E1 equals 0, and then do it. Say I1 R1, what I am writing, I1 R1 minus I2 R2, whichever you are following, everywhere you have to follow the same way, plus E2 minus E1 equals 0. Okay, that is KVL. Next, further, Wheatson's network, most important again in this Wheatson's network. Only just I will do this, and again I will be giving some important questions. I will be giving, you try to work out Wheatson's network. What is Wheatson's network means? Say it is a network consisting of 4 arms, 4 resistances connected in the form of a quadrilateral. 4 resistances connected in the form of a quadrilateral. Like this we will be connecting 4 resistances connected in the form of a quadrilateral. in the form of a quadrilateral. Between two diagonally opposite corners, a galvanometer is connected. Between the other two diagonally opposite corners, a cell of EMF E is connected. A cell is connected. We call this as P, Q and R and S. That's it. This is a Wheatson's network. What is Wheatson's network means? You have to say like, in Wheatson's network, 4 resistances are connected in the form of a quadrilateral. Between any two diagonally opposite corners, a cell is connected. Between the other two diagonally opposite corners, an EMF, a cell of EMF is connected. Okay. Now here, condition for balance of Wheatson's network. Condition for balance of Wheatson's network. So this is one important 5-mark question. Condition for balance of Wheatson's network. Most of the students will never leave this. They will be doing this. Balance Wheatson's network. What to write? You have to take like this only. A Wheatson's network consisting of what? 4 resistances, A, B, C, D. And if you want, call this as E. Here, take current as I1. Here, current as I2. Okay, this is I. And here, however, I will come out. Okay, here, I5 or IG you can call current flowing through the galvanometer. Here, I4. Here, I3 I will take. This is I3. Here, I4 I will take. Come on, see. You take like, consider a Wheatson's network consisting of 4 resistances P, Q, R and S connected in the form of a quadrilateral. Let I1, I3, I2 and I4 be the currents flowing through P, Q, R and S respectively. ನೋಡ್ಕೊಳ್ಳಿ ಹೇಗೆ ಹೇಳ್ತಾ ಇದ್ದೀನಿ. I1, I3 ಯಾಕಂದರೆ ನಾನು P, Q ಹೇಳ್ತಾ ಇದ್ದೀನಿ. I1, I3, I2, I4 are the currents flowing through P, Q, R and S respectively. Let IG be the current flowing through the galvanometer. That's it. Okay. Now here, twice you have to apply KCL, twice you have to apply KVL. You will get the result. Okay. Or even we will be asking like, show that P by Q in a balanced Wheatson's network, P by Q equals R by S. P by Q equals R by S. So now here, what to write here is, this is I1 I told. Applying KCL to the node B, to the node B, to the node B. I1 is entering, I1 is entering, I3 is leaving, minus I3, minus IG equals 0, equals 0. Can I write like I1 equals I3 plus IG, I3 plus IG? This I will call it as equation 1. Similarly, applying KCL to the node, okay, D, to the node D. I2 is entering, IG is entering, IG minus I4 equals 0. Now I can put like I2 plus IG equals I4. Not correct again. That is equation 2. I1 equals I3 plus IG, I2 plus IG equals I4. Okay. So now applying KVL, twice you have to apply KVL, applying KVL. Whenever you apply KVL, it should be to the mesh only, to the closed path only. KVL will be applied to the mesh. KCL is applied to the node or junction always. So applying this KVL to the mesh or closed path, ABDA. I take first ABDA. It must be closed, ABDA, then only it is closed. I will write I1P plus IG into G minus I2R, not called Ray, minus I2R equals 0. I am coming in this way. You can assign one direction, any one direction you can assign, you can go ahead. I1 into P plus current into resistance minus, because for your direction it is coming in the opposite way. Okay, if you want, call that itself as 2 or 3, or even one more step if you want, I1P plus IG into G equals I2R, equals I2R. Let me call this as 3. Okay, next apply for this also. Same way you apply I3Q minus I4S I3Q minus applying KVL to the mesh BCDA, ಬರಿಬೇಕದನ್ನ BCDA, I3Q minus I4S minus IG into G equals 0. Then I can write I3Q minus, that is equals I4S plus IG into G. I can write like this. I'll call this as 4. Now you have to assume one condition. What is that condition? Means current flowing through the galvanometer to be 0. You are assuming that current flowing through the galvanometer is 0. When you assume current flowing through the galvanometer is 0, you see here this is 0, I1 will be equal to I3. Equations 1, 2, 3, 4 becomes, I write like I1 equals I3, I1 equals I3, this will be 5. And this is I2 equals I4, not called really, I2 equals I4, this is 6 I'll call. And what about this 3? This term becomes 0. I1P equals I2R. Okay, this is 7 I'll call. Next, I3Q equals I4S. Come on, why you are getting it? I4S. Okay, this term 0, and here this term becomes 0, and here this is 0, and this is 0. Now what to do, dividing equation 7 by 8. Equation 7 by 8. Come on, what do you get? I1P divided by I3Q equals I2R divided by I4S. Call it as some 9 or something. Next, from these equations, already I1 equals I3, I2 equals I4. From equations 5 and 6, I1 I3, I2 I4 equal. What is left? P by Q equals R by S. ಇದು ನೋಡ್ಕೊಳ್ಳಿ ಆಮೇಲೆ meter bridge. Okay. So this is almost we have covered. And again in electromagnetic waves, I was telling like electromagnetic waves. I'll tell you a few things. You just try to go through them. What and all you have to learn, I'll be telling in electromagnetic waves. That chapter also, don't leave that chapter. So that is electromagnetic waves, definition of displacement current, and the significance of displacement current, and Maxwell's equations, 4 equations, all the 4 Maxwell's equations, you just go through them, Maxwell's equations. Okay. That will complete this part. This part you will be getting good lot of marks. And now in electrostatics, ray optics, wave optics, I will be just telling what are quite important. Only those things I will be telling. Okay. Because if it is a live, and if you want me ask, if you are asking one particular question, I could have discussed it. But now I will be listing out some questions. Go through just electrostatics. Start with Coulomb's inverse square law, because without knowing that, further things will be difficult. Coulomb's inverse square law. Okay, inverse square law. Then concept of electric field, that is E equals, expression for that, E equals 1 by 4 pi epsilon naught Q by R square, electric field. And then what, here electric dipole, already I have explained, electric dipole, okay, and electric dipole moment, and electric lines of force, electric dipole moment. But here those two expressions are important. Electric field near a dipole, on the axial line, on the equatorial line, you should know those things. And after that, some important things, Gauss law. Okay, applications of Gauss law. This Gauss law I told already, phi equals 1 by epsilon naught q, 1 by epsilon naught q. By making use of this, how to obtain electric intensity near what? A thin wire, a thin long wire. It will be very simple. When you take a thin long wire, you have to go for concept of lambda. Lambda is q by L, charge per unit length. You have to construct one Gaussian surface in the form of a cylinder. These are all quite simple things actually. You have to take one infinitely long thin wire we will be taking, which is charges plus q, or lambda is the linear charge density. And one point you have to consider, surrounding the point you should always go for what? You should always go for Gaussian surface in the form of a cylinder only. In the form of a cylinder itself, you have to take one Gaussian surface. Okay. And after taking that Gaussian surface, what to say now? Here, phi is 1 by epsilon naught q. At the same time, phi equals, you have got E dot ds. Okay. So now, that is, ds is nothing but here, cylindrical surface you are taking, cylindrical surface. ds is nothing but 2 pi rl, because length, if you take it as L, some surface you are taking, length is L, E into 2 pi rl. E into 2 pi rl, very difficult to explain like this actually, step by step it will be okay. Then q by epsilon naught, q is nothing but lambda by L, epsilon naught. Okay. Now, what is E equals? E equals, you can get the expression, E equals lambda by 2 pi epsilon naught r will be getting, or otherwise you say phi is E into 2 pi rl, and this is phi is q by epsilon naught L, lambda is q by L, q is lambda into L, L cancels. So what is E equals means? E equals means you are getting lambda by 2 pi epsilon naught r, that's it. See here, you are considering one wire, infinitely long straight uniformly charged wire. Let lambda be the linear charge density. Sir, at a point P somewhere, this is the wire. Here I need electric intensity. I have to consider one Gaussian surface in the form of a cylinder surrounding this point of length L, and radius r. That's what I am telling. Through this, what is the electric flux means? E dot ds. ds is nothing but 2 pi rl. So again, phi equals, according to Gauss theorem, 1 by epsilon naught q. Just compare, q is lambda L, enough, you will be getting it. That application. And again, electric field due to an infinite plane sheet of charge, and then due to a sphere is also important. Due to a sphere, electric intensity near a sphere. Near a sphere means one sphere will be taking like this, one sphere which is charged plus q. This is R, capital R. Somewhere I need here, you have to construct one more Gaussian surface in the form of a sphere only, in the form of a sphere. This is charged with plus q. This distance, if you want, you can take it as some r. Always you have to go for a Gaussian surface. Okay. And again, you consider some small element, through which electric flux is what? E is acting like this. E is acting this way. Normal to the surface is also like this. What is phi equals? Phi equals or d phi in any way? E dot ds. And phi equals E into sigma ds. E into sigma ds is nothing but 4 pi r square. According to Gauss theorem, it is nothing but 1 by epsilon naught q. Equate them. When you equate them, you will be getting this as E into 4 pi r square equals, say, ಎಷ್ಟು simple ಅಂತ ನೋಡ್ರಿ ಇಲ್ಲಿ, q by epsilon naught. Okay. E equals, what do you get? Q by 4 pi epsilon naught r square. Okay. That is the expression. Further, if you want, you can make it as in a different way also. If you want, q by 4 pi r square can be taken as sigma, then it will be sigma by epsilon naught also. Okay. That you please go through that. Okay. Next in this, we will concentrate on electrostatic potential. definition of electrostatic potential, definition of electrostatic potential or electric potential, and relation between electric potential and electric intensity. Show that electric intensity is negative potential gradient. Show that electric potential is negative potential gradient. And electric potential due to an isolated charge, point charge, an isolated point charge, electric potential due to an isolated point charge. You should get the formula V equals 1 by 4 pi epsilon naught Q by R. Most important things I am telling. Next, electric potential due to a dipole. If possible, try this. Electric potential due to a dipole. Maybe if you feel like this is quite complicated, leave it. But whereas if it comes in the exam, you should not ask me. Okay, electric potential. If it is possible, you can leave that and you can do some other thing. And again, capacitors are quite simple. And about potential energy of the system of charges. Potential energy of the system of charges. Okay, equipotential surface definitions. What is capacitance? What do you mean by parallel plate capacitor? Expression for parallel plate capacitor. And again, energy stored in a capacitor. That is also important. Energy stored in a capacitor. Next, it is parallel and series combination of capacitors. Parallel combination and series combination. Don't leave that. Okay, just like resistances in series and resistances in parallel, how you have done. In the same way, capacitors in series and capacitors in parallel, you practice. You have to practice that. And parallel plate capacitor, you try. Okay, parallel plate capacitor. And even if you are leaving this, okay, but whereas don't leave that parallel plate capacitor, expression for parallel plate capacitor. And moving charges and magnetism, almost quite tough. But Savart's law, because for the supplementary students I am telling, otherwise it is not tough, we can do it. So that is, one lengthy expression is also there. That is like magnetic field at any point on the axis of a circular coil carrying current. If possible, try. Otherwise, leave that. And what I am telling, torque acting on a dipole due to magnetic field. And again, potential energy of a system due to dipole. Those things. Okay. Now getting back to almost ray optics. In ray optics, quite important things I am telling, because already in that part you are thorough with modern physics. You are on safer side already. You are clearly on safer side. Okay, in ray optics, very first show that R equals 2F. R equals 2F. Mirror formula. Sign convention. Mirror formula and sign convention. Enough, see these things. And some definitions like what is principal focus, what is radius of curvature, what is principal axis. Those things you should have. But most important is sign convention and R equals 2F and mirror formula. Okay. And then this is concave mirror, convex mirror, and all those things will be getting mirror formula. You try to know. And further, in case of refraction, what do you mean by refraction? Snell's law of refraction. Okay, Snell's law of refraction. The phenomenon in which change in path of light is observed when a ray of light travels from one medium to another medium. That is called as refraction. Okay, thus that formula. Lateral shift formula you try to remember. Normal shift, when a ray of light, when you are viewing an object kept in denser medium and seeing from the rarer medium, it appears to be raised. Those formulae. But total internal reflection is important. Total internal reflection. And show that n equals 1 by sin c. What is total internal reflection? What are the conditions for total internal reflection? What are the conditions? Ray of light must travel from denser to rarer medium. And the other one is angle of incidence must be greater than critical angle. And n equals 1 by sin c. Coming to refraction through prism, very first n equals sin a plus d by 2 by sin a by 2 expression. Try to know that. Sin a plus d by 2 by sin a by 2. Relation between refractive index and the angle of the prism and deviation. Okay. Further here, in lenses first, n2 by v minus n1 by u equals n2 minus n1 by r. N2 minus N1 by R, N2 by V, that is Ni by V also you can write. Refractive index of image space, refractive index of object space divided by object distance, N2 minus N1 by R, and lens maker's formula. These two you concentrate. If possible, try to concentrate these two. Lens maker's formula, lens maker's formula, and even effective focal length. That is quite easy. That is like series combination, parallel combination. When two thin lenses are kept in contact, okay, what is the expression? 1 by f equals 1 by f1 plus 1 by f2, 1 by f1 plus 1 by f2. That is separated by distance, it is a different thing. And power of a lens, ability of a lens to converge or diverge a beam of light. Okay, and optical instruments, little you go through optical instruments, like what is that, simple microscope and all those things, just go through. Coming to wave optics, most important things I will be telling, just go through with this wave optics. Okay, here verification of Snell's law, so that is due to reflection and as well as reflection, Huygens principle. Okay, that is due to reflection and as well as refraction, both are important. Okay, then just Doppler effect formula, only Doppler effect formula, and what is that, violet shift and as well as or blue shift or red shift, what is the meaning of it. Okay, then interference, very first one, theory of interference, how that interference arises because of principle of superposition, that you try to have an idea, theory of interference. And then conditions for constructive interference, destructive interference, fringe width experiment, I mean Young's double slit experiment, expression for fringe width, okay. And then diffraction, if possible try that, diffraction due to a single slit, okay. Resolving power of a microscope, resolving power of a telescope, and resolving power of a telescope, okay. Then in polarization, what do you mean by polarization? Methods of polarization, mention of methods of polarization, Brewster's law is important, okay. If possible, about some polarides, you try about polarides, okay. This is about polarides. Coming to EMI, Faraday's laws of electromagnetic induction, and E equals BBL, just see these things, we will see, okay. But you must be thorough with all the other things. When you are thorough with all the other things, then only you can do all these things, then only you can take a choice. If you take a choice in each and every chapter or each and every topic, it will be very difficult. I am telling, once again I am telling, you see, be ready with dual nature of matter and radiation, atoms, nuclei, semiconductor, electronics, and further magnetism matter, alternating currents, okay, electromagnetic waves concept I told, and then what, and then current electricity. You are completely safer, totally safe. Once again I told you many times, that is 5 plus 5 plus 6 plus 9, and then 13 plus 7 plus 7 plus 3. This is magnetism matter, alternating currents, electromagnetic waves, current electricity. Here only 30 marks, and this is 25, 55 marks, and then you can play. Then you can play means what? You can take choice. You can take choice like electrostatics. In electrostatics, Gauss theorem and applications of it. Very, very important. Gauss theorem and applications of it. Maybe you might feel difficulty with electric field due to dipole, axial line, equatorial line, and even potential due to dipole also you might feel difficulty. Okay. So those things are different, but Gauss law, and again parallel plate capacitor, and capacitance in series and capacitance in parallel. In ray optics, don't leave R equals 2F, mirror formula, and then lens maker's formula, practice, okay. And then N equals sin A plus D by 2 by sin A by 2, and even if possible try that N2 by V minus N2 by U, okay. Wave optics, briefly you just go through, and have confidence. I am telling, have confidence and you can do wonders. It is not a big thing at all. I am telling. You can do it. Definitely you can do it. And have some concentration and as well as confidence. And that is what I am telling. In the last examination, maybe some people may not be feeling well. And sometimes, throughout year you have studied. And the day of examination something happens. Sometimes because of stress only. Okay. And again, don't think of these things, question paper leakage or something like that. Don't try for that. Instead of that, sit and work out. Okay. Nowhere. Don't think like question paper will come out or something like that. Why do you do it? Always I'll be telling. Once if you know the paper, say tomorrow you are supposed to write the exam. Today you are getting the paper. I'll tell you, I don't feel like writing the exam if I see the paper early. If I see the paper early, what is the thrill in writing the exam? You should never see it. You have to see the question paper only in the examination hall. Then only you will have a thrill in writing the exam. Earlier only if you come to know what is there, nothing is there in it. Prepare, I am telling. Let anybody set the paper, questions will be there. Prepare like this. If you prepare and tell me. If you are not prepared, you don't ask me. Okay. You have to follow whatever we say. Definitely you can do. So it is nothing. Now also I am telling. Scoring around 50 out of 70. It is very easy. 50 out of 70. You should do it. You should do, and you have to prove like something happened in the last examination. Others should feel like this fellow is good, but something somewhere some mistake happened. In that way it should be. Okay. Again if you fail, there is no meaning. There is no meaning. I say in physics, no question of failing. Okay. I will be telling, if you prepare like this, these chapters, I told some chapters you prepare. I will be always telling, failing is difficult in physics unless you have determined and decided to fail. Unless you have determined and decided to fail, then only you will fail in physics. Theory. Competitive exams, little difficult. You should have a complete depth. But here, some important points if you go ahead and you can do it. Okay. So now, I wish you all the best for your exams and do well. Not only this paper and all the other papers also, you do well. Tumba chanag madri. And then you try to take up CET already you have written. Some rank you will be getting. Definitely I am telling, getting into engineering is nothing. Getting into engineering, BE is nothing. You will get the seats. Many students who have cleared in supplementary, they got seats. And just many people will be telling, any course you take, don't take up BE. I will be telling, take up BE. People will be telling like that. Don't take BE, go for BS. BS is also good. If you do BSc, MSc, PhD, yes, very good, bright. But whereas, who are not getting jobs in BE, I am telling, you will enter into BE, you will get around 50 to 60% in BE. Knowledge also not there. After completing BE, no MNC will take you without conducting exams. There will be one first round exam. First round, that is just numerical things. Aptitude test, only numerical things, the numerical aptitude, whatever you have studied in 9th and 10th mathematics, basic mathematics. Okay. Second round will be technical round, what they test, not what you have studied, what you understood. What you understood, how do you apply, that will be there. Third round they call HR round, and fourth round they call group discussion. Your ability in English, communication skills in English will be tested. And after that interview will be there. Most of the people will fail there. Even the students who got 70%, they will fail in these exams. Say I am telling, get some 85% in BE and then be little intelligent. You will get jobs. Jobs are there. Only the students who are telling like that, they are not able to. I will be telling, BE is eligible for the jobs. After completing BE, you are eligible for the job, but you are not fit for the job. You are not fit for the job. Try from second year, third year onwards only, try to do all these things. Take up some numerical aptitude things, aptitude tests and all. Subject knowledge you develop and learn the language. Let me say why you don't get it. You will get it. It is possible. Okay. It is possible. If not you, who can do it? I will be always telling, if not you, who can do it? Have confidence. And again, if you take up that BE, this is a graduation, not just doing some software or something like that. You are eligible for probationary officers, bank exams. You have done BE, your mathematical background will be good, you can clear it. Okay, you can take up KS, IAS exams, IES exams, Indian Engineering Services exams. Many possibilities are there. Okay, there are many possibilities. You should not be lost here, and so you should not be get discouraged by others also, and you should not lose confidence. You must be confident. You can do wonders. That is what I will be telling. Somebody says something is tough, I will be always telling. Some problem or some subject, let me say physics is tough, somebody says, I will be thinking, let me see how it is tough. Let me see how it is tough. Some problem is tough, I will be telling, let me see how it is tough. I will tell you, you have to think in that way. If somebody says something is tough, you have to think like, let me see how it is tough. I will tell you, you are tougher than anything. You are tougher than anything you can achieve. So you please do it. Okay. So all the best once again, and do well in the exams. And so try to recall step by step and try to go ahead, and all the best, and all the best for your future also. Thank you one and all.